Okay, so this one talks about mutually exclusive events. So events are mutually exclusive if they are completely separate from each other, okay, and have no overlap. So what is the probability of drawing an ace or a face card from a deck of cards? So tell me, how many aces would there be to pick in a deck? 4. Or, so I should add, or I could get a face card. So how many face cards are there in that deck? Jacks, queens, kings, 12. Out of cards, all options. Is this mutually exclusive, yes or no? Yes, there was, the aces and face cards had nothing to do with each other. What's the probability of drawing a heart or a face? So how many hearts are there to pick from? 13. Or face cards, we just did 12.
But wouldn't you, because there's 3 cards?
Yep. Okay, but what happened here? There's an overlap. So when I did the hearts and the face cards, we did the jack of diamonds, the jack of hearts, the queen, okay, did you notice how these cards got counted when we counted hearts? And those cards got counted when we did the face cards. So we counted them double. So that's an overlap. So what am I going to do? I'm going to subtract. Does that make sense?
Wouldn't it be 6?
What did I do?
Shouldn't it be 3 because it's just hearts? That's what I meant, 3.
Oh, hearts. Yeah, sorry. I was thinking red. My bad. Yep, thank you. Sorry. There we go, 3. In my brain, I was doing red cards. There. That look better? So 13 plus 12 minus 3. So 22 out of 52. So is this mutually exclusive? No, they're not mutually exclusive because there was that overlap part. Okay, rolling a sum on 2 dice. Ooh, what do? 2 dice. What do you start the strategy? As soon as you roll 2 dice. Chart, is that what you're saying? Do that? Who can beat me making this chart? Okay, so rolling a sum greater than 8. Don't be on 8, you got to be greater than 8. So I can do 9s, 10s, 11s, and 12s. I can get those sums. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 possible things there. Or getting a multiple of 5. So I could have rolled a 5 or a 10. So 1, 2, 3, 4, 5, 6. There's 7 options there. But, you notice something? I counted these 3 items. You can see my yellow and my pink. So I don't want to overcount them. So really all you have to think about is how many at the very end are somehow highlighted. Okay, so you could do this. So 17, so that's 14 out of how many always on this dice thing? 36. Or you could literally just go in here and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, but the mutually exclusive part, that's not happening. Okay, this one is going to be what do you think? Remember these things? Venn diagrams. With the universe. Okay, I read somewhere on your provincial exam, if you don't have a box around your Venn diagram, you lose a point. So circles and a box, because there could be stuff outside of your bubbles, right? Okay, eating habits, not study habits. Okay, let's go with a B and an L, breakfast and lunch. I think we're gonna go that they skip. These people are skipping breakfast and these people are skipping lunch. Okay, 62 skip breakfast. So do you understand that this entire bubble has to add up to 62? But I don't really know because I'm going to probably have a number here and a number here, but they would add up to 62. I don't really know what to do here because this and this need to add to 24. Don't know. 22 eat both meals. I can put that somewhere. Where can I put that? Outside. Because they don't skip anything. Okay, so tell me, how much should I have in my bubbles, anywhere inside my bubbles? What should I have altogether? If there's 22 out of mine, I should have 78 in my bubbles somewhere. Okay, so this one had 62 and this one had 24. So what is that? That is 86. Do I have room for all that in my bubble? No, I'm only allowed to put 78 in my bubble. Therefore, what is the overlap needing to be? Yep. So I need 8 in my overlap. Okay, so now we can finish this out. 62 skip breakfast. So 8 plus, what? Is it 54? And then I need to put 24 in the L bubble. So 8 and 16. So are these events mutually exclusive? No, they had some overlap. Determine the probability that a randomly selected student skips breakfast. Apparently I couldn't write the whole word. They skip breakfast, but they don't skip lunch. Which one is that? They're skipping breakfast, but they're not skipping the lunch. 54%. This is a percent because that's what we were talking about. Determine the probability the randomly student skips at least one breakfast or lunch. At least something. What are you going to do?
Add up everything in the bubbles.
All the bubbles, which is, should be 78, right? They have to do one or the other. How do you do an or statement? Or, that's an or statement, right? So you can add them all up. What? Where did what?
What about the 86?
The 86 was when I added those two up, but that was too much. You can't have 86 and 22 because that's over 100%. So now you have to take that 86
Yeah.
and subtract what should have been in the bubble, because then that is your overlap piece. Does that make sense? Because remember when we said there only is allowed to be 78 in the bubble because there's 22 out. There's only allowed to be 78, and this was 86. You can't fit that in the bubble.
Yeah.
So now you have to have something that was overlapped, which is why there's a double count.
Okay.
I don't know. Did I explain? A mother wants to buy a new washer and dryer, $2,500, 1-year warranty. She can buy a 3-year extended warranty for $450. So she does these statistics to see what she should do. Okay, so we're going to talk about the repairs on washers and dryers. Okay, so 22% of people repaired their washer, 13 repaired their dryer, and 3 repaired both. What can you do right now? 3 repaired both. What's left inside this washer? 19. What's left inside the dryer? 10. What would you put on the outside of the bubbles? $68. Okay, so what does this all mean? Okay, so she would have a 19% chance of just the washer, which would cost $400. There would be a 3% chance that she would fix both, which would be a cost of $700. There is a 10% chance to replace just the dryer. That's a $300 fix. And there's a 68% chance there's no fix needed. So would you tell this person to spend $450?
No.
No. Because really that's the only big hit, and guess what? There's only a 3% chance that you'll have to pay $700. So I would say not recommended, and then kind of explaining why. Well, $450. Well, look at, there's a big chance you're not going to have to pay anything anyway. So I would just go for the risk. Okay, and the last question. Heated leather seats in a car. Sunroof. Leather seats and sunroof. Okay, 43% have leather seats, so I can't do anything because this and this will be 43, but I don't know. 36 have the sunroof, don't know because that has to add to 36. 49 have neither. Put that on there somewhere. 49 don't have anything. So tell me, what should I be putting inside the bubbles altogether? What's left to go in? 51 can fit in there, right? But what did you have here? You had one that had a 43 and the other one had 36. I can already see that's way too much to put in there. What is that? 79? That's too much. I can only fit 51. So what do I count twice to lower that number? $28. So the whole leather seat has to add up to 43. And then this side has to add to 36. So the question says, the probability that you would have both. So what's your final answer of having both? Your answer is going to be 28% is the chance that you're going to have both items.